Hello, everyone. I welcome you to this recording. For today, I'm going to go through a topic known as electrolysis. And I want to assist all level learners there who have challenges in electrolysis to ensure that we improve on the understanding of chemistry and how best we can score in terms of this topic. But before I handle anything, I would like to request whoever is watching this video to share the link to other members who have challenges in this area. And in case you have not yet subscribed, please subscribe to this channel. Smart Science is my name. And follow my episodes to ensure that you understand this particular topic. We are going to have a series of episodes on electrolysis till when we complete it, and we see how best we can answer electrolysis. To begin with is a definition that if you are told to define electrolysis, this is the decomposition of an electrolyte by passing an electric current through it. And to demonstrate this, or to show you a simple demonstration, the demonstration setup, you will see that the whole process works like a battery, a local battery, you know. The local battery has two basic terminals. One terminal is a positive, and another terminal is a negative. So if this is the DC source, or the source of current, you will see that the long bar represents a positive and the short bar represents a negative. Then we shall have a liquid inside an aqueous solution, and this aqueous solution, we shall call it the electrolyte. So the moment you continue passing an electric current through this liquid, it will decompose, and the entire process will be called electrolysis. The terminal, which is connected to the negative terminal, is going to be called the cathode, and the other, which is connected to the positive terminal, is going to be called the anode. However, collectively, both terminals are going to be known as electrodes. One is positive as the other is negative. Then whenever a terminal is negatively charged, it means it has plenty of electrons. Therefore, electrons will be flowing from the negative terminal into the electrolyte. So this arrow is showing flow of electrons. Therefore, in the opposite direction, it will be flow of current. So current flows in the opposite direction to that of the electrons. Therefore, from this demonstration, you realize that we have new terms we are coming up with. The first term is an electrode. The first term is an electrode. By definition, is a conductor of electric current that allows current to enter or leave the electrolyte. So current will enter or leave the electrolyte through a terminals we call electrodes. These electrodes are going to be categorized into two. The first electrode is the anode. First electrode is the anode, which is positive. So it is a positive terminal. Still, this anode, we can call it, we can say that allows current to enter the electrolyte. The anode still only attracts and discharges, negatively charged ions, what we call anions. The anode still involves reactions which allow loss of electrons, and when a compound loses electrons to the terminal, it becomes oxidized. So we are going to say that involves oxidation reactions by loss of electrons. That is the anode. The other electrode, we call it the cathode. The cathode is a negative terminal. In simple terms, allows current to leave the electrolyte allows electrons to enter the electrolyte. It attracts positive ions, which we call cations. Discharges ions by a process known as reduction or gaining of electrons. So if you meet a question which says state the difference between cathode and anode, we can put like around 3 marks or more, or 2. So depending on what we have presented to you, you can put your differences in form of a table. One side cathode, another side anode. Then you suggest your differences. Negatively charged, positively charged. Reduction occurs, oxidation occurs. Discharges, cations, discharges, anions. Allows current to leave the electrolyte, allows current to enter the electrolyte. Allows electrons to enter electrolyte. Allows electrons to leave the electrolyte. So those could be some of the differences between cathode and anode. However, you can continue and come up with more differences. We are giving up some such that we don't waste a lot of time. The other aspect in electrolysis, we are going to meet electrolyte, and when you're requested to define an electrolyte, this one is an ionic compound that conducts current in aqueous or molten state. In aqueous or molten state. So if it is supposed to be ionic, it means we are only going to look at ionic compounds, e.g. Sodium chloride, sodium hydroxide, sulfuric acid, silver nitrate, etc., among others. The types of electrolytes are going to be borrowed from acids, bases, and salts. If you still recall that, we have those ones which are strong electrolytes and weak electrolytes. The strong electrolytes, we shall realize that this one is completely ionized in aqueous state. They have a higher conductivity of current. These ones form many conducting ions. They conduct by ions, therefore form many conducting ions when they completely ionize. Examples come from mostly ionic normal salts. The others are going to be strong acids and strong alkalis. Normal ionic salts like sodium chloride, strong dilute gas acids like sulfuric acid, HCl, nitric, strong alkalis like sodium hydroxide, potassium hydroxide, among others. The other type is weak alkalis. Weak electrolytes. Weak electrolytes. These ones partially ionize in aqueous state. They have a lower conductivity of current. They form fewer conducting ions. Examples of such electrolytes include: number one, ionic acid salts. For example, sodium hydrogen carbonate, among others. We have weak acids, for example, carbonic acid, among others. We have weak alkalis, for example, ammonium hydroxide. The questions you will find here is: state the differences between strong and weak electrolytes. Strong and weak electrolytes. Watch our next episode to look at the continuation of this. I still remind you that subscribe to my channel, which is Smart Science with a DNA logo. Watch the next episodes of our discussion. Thank you very much for watching this video. For those who are up there, please continue subscribing and make sure you follow us on YouTube. Thank you very, very much.